All right, we're going to finish the notes today. Happy Monday, May 9th, 2022. It's National Lost Sock Memorial Day. We have victims in my house too. I don't know how it works. Put them in the dirty clothes. They go in the washer. You pull them out of the dryer. They're missing, right? So we keep them in the laundry basket. We just keep hoping they'll show up. There's like 3 or 4 in there that don't have partners, and instead of finding the matching pair over time, they just get more friends in there that are lost. I don't know how it happens. I don't know where they go. But today we give honor to all those lost in the heat of the battle, in the tumbling of the dryer. 1960, the U.S. becomes the first country to legalize the birth control pill. The birth control pill, of course, and now it was leaked that the Supreme Court is going to overturn Roe v. Wade, leaving it up to the states. So isn't America a great place in which to live if you can make it into existence in America? With the birth control pill and abortions, trying to prevent you from that happening. Once you become an American citizen, it is the greatest country in which to live. And happy birthday, speaking of Americans, Billy Joel, who turned 73 today. Billy Joel, along with Elton John, 2 of my favorite pianists. And then Howard Carter, who on this day in 1873 was born.
Yes.
And who later in life, along with Lord Carnarvon, discovered the tomb of King Tutankhamun, also known as King Tut, and they became the most famous grave robbers in the world, right? Yeah, right. Yeah. So, yeah, I know, right? It's interesting. On the one hand, it's interesting so that we can kind of learn about history and their customs. But on the other hand, like you said, they're grave robbers. They're sanctioned grave robbers, and rest in peace. not if we find it. Not if we find your grave. Rest in pieces, right? Or as what's not Metallica, but the other one he broke off. What's his name? Megadeth said, "Rust in peace." Rust in peace. That's an album name. Okay. Anyway, I said we weren't going to mess around today. We're going to go straight to the math, and that's because we are going to finish the math. There's 2 examples left to go, but example 11 has 6 of them. So, whatever, 7. And then the notes and the worksheet are both going to be due tomorrow morning. That's Tuesday by 9 a.m. Okay, 9 a.m. All right. So here we go. We are solving trigonometric equations, possibly with the use of identity. First of all, it says find all the solutions from -4 pi to 0. And we talked about that variable being psi. So remember what we're going to do. Regardless of the interval in which our solutions have to live, we're going to find all the ones in our comfort zone first, right? Which is 0 to 2 pi. And then we'll adapt. Okay. For in this case, it's 2 negative rotations. So let's go ahead and set out to find them between 0 and 2 pi. All right. 3 sine of psi equals 2 cosine of psi. You know what? If you don't like psi, guess what you can do? From the very beginning, you can just call it x. Do it from the very beginning. All right. I'm okay with that. Now, what do we do if we have at least 2 variable terms that are unlike terms, like x squared and x in algebra 2 or in here? Get everything on one side, set it equals 0 and try to factor. Yeah, that's what we do. So no difference here. So 3 sine of x minus 2 cosine squared of x equals 0. I tend to get everything on the left-hand side. Okay, now we look for a common factor. The problem is there is no common factor. X is the angle, so that doesn't count. We got sine and cosine squared. If it was sine and sine squared, we'd be able to pull out a sine. Or if it was cosine and cosine squared, we'd be able to pull out a cosine. But wait, aren't there identities that allow us to do that? Is it easier to write sine in terms of cosine or cosine squared in terms of sine squared? I know it's a big question on a Monday morning, but you have your identities memorized. So if we write sine in terms of cosine, it's going to be the cofunction identity. And that changes the angle, remember? Pi halves minus x, yucky, gross. We don't want that. But cosine squared, we know from Papa Pid, we can easily write it in terms of psi squared and keep the angle the same, yeah? So that's what we're going to do. Now put this in parentheses because there's something in front of it, especially a negative. We're going to replace that with a 2-term dude. So here we go. A la Papa Pid, cosine squared becomes what? 1 minus sine squared. Yeah, remember, those 2 versions of Papa Pid be used more often than the Papa pit itself. 1 minus sine squared is cosine squared, and 1 minus cosine squared is sine squared. Okay, now we can distribute, right? If we distribute, we get 3 sine of x minus 2 plus 2 sine squared of x. And now we're like, oh, I know how to do this. I got a squared term, a non-squared term, and a constant. That's a quadratic trinomial, but instead of terms of x, it's in terms of sine. Where did we do that? Didn't we do that? We did that up here in example 7, right? Squared term, non-squared term, and a constant. We factored it. No difference here, right? So let's write it in descending order. 2 sine squared of x. Oops, that should be sine squared. 2 sine squared of x plus 3 sine of x minus 2. Now we look for a common factor. Is there a common factor of a coefficient of anything? Can we factor out a 2? No. Now at this point, if your leading coefficient were negative, like if that were a negative 2 sine squared, I would either factor out the negative or multiply both sides by a -1 and distribute, because it's a lot easier to factor, remember, when your leading coefficient is positive. So this one is going to factor into the product of 2 binomials again. The coefficient of sine squared is 2, it's prime. So I know the first one has to be 2 sine and 1 sine. And then the last one, 2, the constant, is also prime. So it's got to be either the 1, 2 or the 2, 1 combo. I'm going to try the 1, 2 combo because I need to get a 3. So the sum has to be a positive. So my 4 is going to be a positive, and then the -1 will be a negative. So that should work, right? The outer gives me -1 times +2, which is -2. The inner and outer sum gives me a +3, right? +4 on the outside, -1 on the inside. 4 minus 1 is +3. So you should be becoming increasingly accustomed to factoring things like that with sine or cosine instead of just plain old x. And now once we have it factored and equal to 0, we can set each of them equal to 0. So 2 sine of x equals 1, or sine of x equals -2. Do you see what I did there? I skipped a step. Is that okay? Set it equal to 0, but I also brought the constants to the other side and changed their signs. So now I'll divide through by 2. I get sine of x equals 1/2. And then sine of x equals -2. That's just ready to go. Okay, so now it's unit circle time, or time circle unit. We got to use the unit circle in reverse. Let's go ahead and find the solutions in our comfort zones, 0 to 2 pi. I'm not going to show taking the inverse sine of both sides. Remember, I'm just going to say, okay, sine of what angle is 1/2? Bless you. Where's sine, the y ratio, equal to, bless you, +1/2? There's 2 places, right? Quadrant 1 and quadrant 2 should be pi/6 and 5/6. Yeah, pi/6 and 5/6. That's Monday morning, right? I'll help you out there. Now that's between 0 and 2 pi. Let's look at the next one. Where is sine equal to -2? Sorry. Where is sine equal to -2? Sorry. Where's sine equal to -2? Never. D and E. Sine has to stay between -1 and 1. So this guy is D and E. There's no solutions, right? No solutions from that piece. Okay. Sine is never -2. Now, all we have to do is modify it in the prescribed interval, which was from -4 pi to 0. All I got to do with each of these 2 solutions is find their coterminal brethren that are 2 negative solutions away, right? So all I got to do is subtract 2 pi twice from each of them. So let's do that. What's a good version of 2 pi to use here for counting by 6? 2 pi is how many sixths? 12 pi 6, right? So let's just subtract 12 2 times from 1 pi 6. What's 1 pi 6 minus 12 pi 6? One more time. -11 pi 6. So that's the one from -2 pi to 0. I don't like the way I wrote that. -11 pi 6. And now subtract one more time from 11 pi 6, or 12. What's -11 minus 12? -23 pi 6. That's the one between -4 pi and -2 pi. Now, if I did it one more time, that would exceed -4 pi, right? -4 pi would be -24 pi 6, right? So we're just short of that. We're a pi 6 short. So that's what this guy gives us. He gives us these 2. And then this guy also gives us 2. What's 5 pi 6 minus 12 pi 6? No. Negative 7 pi 6. Good. Yeah. And what's negative 7 minus 12? Negative 19 pi 6. Good. And that's the solution. Since I have them all listed nicely, x equals comma, 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 I don't need to put them in braces as a solution set. Okay. So there you go. If I needed to find all the solutions, it would actually be easier, right? All the solutions would just be pi 6 plus 2 pi n and 5 pi 6 plus 2 pi n, where n is an integer. So all I did to find these two solutions is I let n equal -1 and n equal -2 for both of those. Okay. So there you go. Comments, questions on that? Fun, 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 fun. Easy, fun, easy. All right, good. All right, so the identities there. Put it all in terms of a single trig function, whether it's sine or cosine. Use the PIDs in this case for that. Factor, set them each equal to 0, and then solve. Okay, example number 11, rapid fire. Unlike the stormtroopers, though, we're going to hit our target, right? Mixed practice. Solve each of the following between 0 and 2 pi. And notice we're not including 2 pi. That's the start of the next rotation. So all of these solutions are going to be in our comfort zone, in our wheelhouse, within one positive rotation. No calculator. Pshaw, we don't need it. Now, remember, the first step is important. If you have more than one variable term that are unlike terms, that's when you get everything on one side equal to 0. But if you only have one variable term, you don't get everything on one side equal to 0. You isolate it and solve, right? Okay. 2 sine of x plus square root of 3 equals 0. How many variable terms do I have? 1, right? It's already equal to 0. I don't want it equal to 0. In fact, there's really nothing to factor out there. So with only a single variable term, my goal is to isolate it, not to get everything on one side equal to 0. So I'm going to subtract the square root of 3 from both sides. And again, this is honors pre-cal. We don't show that anymore. We just go right to the next line. Back in the day, you were told to do this, right? We don't do that anymore. We just do it in our head. If you bring a term from one side to the other, you just change its sign. Terms, of course, separated by plus or minus signs. And now we'll divide by 2. And again, we don't show that step there. We don't show that step there. We just go to sine of x equals negative square root of 3 over 2. Did we isolate the variable factor now? Once you isolate the term, you isolate the variable factor. We did. We got sine of x equals. So that's good. And now it's not unit circle time, but time circle unit. I don't like to show the inverse sign of both sides because then you might think it's the function with one solution. We want all the solutions from 0 to 2 pi. So that's going to be this one down here where sine's negative and this one down here where sine is negative. So what's the reference angle where the sine y height is negative square root of 3 over 2? It's a pi thirds angle. Good. So the pi thirds angle in quadrant 3 is what? 4 pi thirds. And the quadrant, or the pi thirds angle in quadrant 4? 5 pi thirds. Good. We're done. That's it. Fun easy, right? Almost fun boring. Too easy. Sometimes it's too easy. It's fun boring. Got to know your identities. Got to know your unit circle, right? It's a good thing that we spent most of the second semester practicing the unit circle and learning the identities first, right? There's a sequence. Yeah. Okay, cool. Comments, questions on that? Rapid fire. Was that rapid enough? Yeah, it's like a rapid fire musket, right? It's not like an automatic weapon, but we're experts with the musket. We could shoot and then back the next round quickly so that we could fire, right? In under 30 seconds. In under 30 seconds. Yeah, very good. All right, letter B. 4 secant squared of x equals 8. Hey, I see a variable. I see one variable term. Do we want to bring the 8 across and set it equal to 0? No. I want to isolate the variable term. The variable term is already isolated. Once the term is isolated, we isolate the variable factor, which, Brady, we divide both sides by 4. So I get secant squared of 8/4, which is 2. Yeah. And now we'll extract the square root of both sides. Secant of x equals what? Square root of 2. Plus or minus. Thank you. If you forget to consider, whenever you take an even root, square root, 4th root, 8th root, whatever, you're going to lose possibly half your solutions. plus or minus when you extract the square roots on the numeric side. Yeah. And now it's unit circle time. Is it? Yeah. So you can do this one of two ways. If you remember when we took unit circle quizzes, if I asked you for a secant of an angle, you sometimes put square root of 2 or negative square root of 2 as an answer. But going backwards can sometimes be harder, right? Right? If you don't believe me, try driving home that way after school, right? In reverse the whole way. Well, Mr. Corpy said, officer. No. We don't have to solve a secant equation, do we? Because if I know a secant ratio, don't I know a cosine ratio as well? Don't I? So let's flip both sides. If the secant ratio is square root of 2 over 1, the reciprocal cosine ratio should be plus or minus 1 over the square root of 2, right? Help yourself, help yourself. Yes? Yeah. Now, square root of 2 over 2 is the more familiar version of 1 over the square root of 2. So yes, that's the cosine ratio. So Brady recognized right away that the secant ratio of square root of 2 was your pi force reference angle. You need to go get some contact relief. Yeah. But if you need to flip both sides and think of it in terms of cosine and then rationalize it, now you're like, cosine and sine are square root of 2 halves. That's your pi force reference angle. And we want to know where it's positive or negative. So we know it's positive here, and then it's negative here. So which of the pi force angles do we want within one rotation? All of them. Yeah. And if you had forgotten plus or minus, you would only be getting the ones in quadrants 1 and 4. So let's list them out. Let's do an order of positive rotation. Pi fourths, comma, what's the next one? 3 pi fourths, then quadrant 3 is 5 pi fourths, and quadrant 4 is 7 pi fourths. There you go. We're Brooks in, done. All right. Rapid fire. Okay. Sweet. Comments, questions on that? Extract both square roots. All right. Number C. Hey, I spy a single variable term. Do we want it equal to 0? No. Let's isolate the term first. So 4 cosine squared of x equals 3, positive 3. Now let's isolate the factor. Divide through by 4. Cosine squared of x equals 3/4. Now we'll extract the square roots again, remembering this time to consider both plus or minus. Now, is the square root of the quantity 3/4 a unit circle ratio that we recognize in this form, is it? If it's a no calculator question, I guarantee I'm expecting you to use the unit circle. So just like 1 over the square root of 2, we have to put it in a different form. We might have to do that here as well, right? Let's work straight down. That's the same as plus or minus the square root of 3 over the square root of 4, yes? Well, that's the same as plus or minus the square root of 3 all over 2. Holy moly smokers. Now I'll bring the cosine down. That looks more familiar. And because it's plus or minus, I want to know where cosine is positive root 3 over 2. That's going to be in quadrants 1 and 4. And I want to know where it's negative, which is quadrants 2 and 3. What's the reference angle where the x, the cosine, is root 3 over 2? Pi 6. So which pi 6 reference angles do we want within one rotation? All of them. Yeah. So it's kind of like the second verse to the same song. Let's list them in increasing order. 1 pi 6. What's the next one? 5 pi 6. Good. And then quadrant 3. 7 pi 6. Good. And then quadrant 4. 11 pi 6. There you go. Fin easy. And easy. We put it all together to save you more at the room store. I mean, what? Too easy, right? What's your comment? It's boring, right?
You could kind of put it into like an integer form if there was no other bound.
What?
It just said like if you wanted everything greater than 0, but it never defined where to stop at.
Yeah. What could you do?
A form of pi 6 plus pi halves n.
Are those 90 degrees apart? Pi 6 and no, they're not evenly spaced, remember. Pi 6 and 5 pi 6 are 120 degrees apart. And then 5 pi 6 and 7 pi 6 are only 60 degrees apart. Hoop scoop, darn it. But if I did want all of them, I could do this. I could say it's your pi 6 reference angle plus pi n. I think that's what you're getting at. And then I could say the 5 pi 6 angle plus pi n, right? Yeah. Normally, I would say x is positive at 1 pi 6 and 11 pi 6 and say each of those plus 2 pi n. But because I want all of them, it will turn out that the positive and negative set are 180 degrees apart from each other. So that's a different way to list all of them. I'm glad you brought that up. Does that make sense? Yeah. So if it did just say list all of them, there's a lot of different ways you could do it. Pi 6 plus 2 pi n, 11 pi 6 plus 2 pi n, or, and that'll list all of these coterminal. Then you have to go over here, 5 pi 6 plus 2 pi n, 7 pi 6 plus 2 pi n. So that would be 4 equations. But because you can see that they're obviously 180 degrees apart, you could say all of them are pi 6 plus pi n and 5 pi 6 plus pi n. Yeah, very good. But I did say to list them all between 0 and 2 pi. All right. Sine of x equals cosine of x. How many variable terms do we have? Two. So normally we want to get everything on one side and set it equal to 0, right? Sine of x minus cosine of x equals 0. And then we look for a common factor. Is x a common factor? No. Is s a common factor? No. So what do we do here? There's nothing to do. If I change cosine into sine because it's not squared, I'd have to use the cofunction identity. And what does that do to the angle? It changes it. That would be minus sine of pi halves minus x. And when you change the angle, you're kind of hamstringing yourself now. So that's not incorrect, but that is not the way we want to go. No. There's two ways to do this, okay? The easy way is, first of all, to just think about it. Think about it. I want to know the angle x within one rotation where the sine y coordinate is the exact same as the x cosine coordinate. Yeah. Very good. If you think about it at pi fourths, I know that they're both what? Square root of 2 halves? Square root of 2 halves. Are those ratios equal to each other? Yes. So x equals pi fourths. Very good. Is there another angle, though, where they are exactly the same? 5 pi fourths. Good. Where they are both what? Negative square root of 2 halves, negative square root of 2 halves. Good. Would the other 2 pi fourths angles work? No, because they're opposites there. That would be if sine equals negative cosine or negative sine equals positive cosine. So that's the easiest way to do that. And believe it or not, we were doing AP calculus review last week, and we got down to solving a polar equation, and we needed to solve this equation. Where does sine equal cosine? Literally, we got down to this exact equation, and I said, hey, how do we solve this? And they're like, hey, like that time in Precal, remember, like on Lost Sock Memorial Day, we said that it was just those two. And yes, very good. Was it really on National Sock Memorial, Lost Sock Memorial Day? I asked them, and they said, no, I made that up. But hey, what a coincidence. It's today with y'all, right? Yeah. So that's the easy way to do it. You want to see the other way to do it? I'll show you the other way to do it. It's a little bit longer, but it's a good strategy, right? If you didn't realize that, you could just think about it. You could actually square both sides, right? Is that a legal thing to do? It is. But when you square both sides, you got to be careful. That raises a red flag. It's a reminder for you to check for extraneous solutions. Remember doing that earlier in the year? When you raise the power of both sides, you bring in higher degrees, which brings in more possible solutions that don't work. Now, once they're squared, I'll bring everything across. Sine squared of x minus cosine squared of x equals 0. And now, how would we solve that if they're both squared? Remember what we did up here? We had them both squared. We changed one in terms of the other using Papa Pid. Yeah, so you could do that now. Let's go ahead and do the first one this time. Let's call that 1 minus cosine squared minus the cosine squared. And so now you get 1 minus 2 cosine squared of x. And now you can separate the variables. 1 equals 2 cosine squared of x. So you divide through by 2 and flip both sides. You get cosine squared is equal to a half. You take the square root of both sides, and you get cosine is equal to plus or minus the square root of 1 over 2. which, by the way, square root of 1 over 2 is the same as 1 over the square root of 2, which is square root of 2 over 2. Okay. And now, because we want cosine to be plus or minus, which pi fourths angles do we want? All of them, right? Pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. Now, the problem is because we squared both sides, extraneous solutions could get in. Are any of these extraneous? Yeah, those two guys actually don't work. How do you find if they're extraneous or not? You have to plug them back into the original equation, and you'll see that those give you the opposite signs, not the same. Now, the reason they jumped in is because if those are negative values, when you square a negative, they become positive, and a positive equals a positive. So that's the algebraic way to do it. Which way is easier, I ask you? Just thinking about it, which is the whole purpose of this class, to get you to think, or the algebraic way that requires this technique that you have to remember to do? That was almost a hypothetical question, right? You don't even have to answer that. But yeah, the thinking way for sure. Thank you. All right. All right. 5 down, 2 to go. You ready? Let's keep trucking. 2 cosine squared minus cosine. How many variable terms do you see that are different? 2. Cosine squared is different from cosine. So in this case, do you want to divide both sides by a cosine and lose a cosine from both sides? No. We can minus a cosine, yeah. And now the cat's kind of out of the bag here. Do we need to change cosine squared into sine squared? Do you want to use a Pythagorean identity here and we call cosine squared 1 minus sine squared? No. The whole purpose of doing that is to get both of the terms in terms of the same trig function, either both in terms of sine or both in terms of cosine. It's already both in terms of cosine. Silly geese. What's the first rule of factoring? It's not a trinomial, so we're not going to factor into the product of 2 binomials, but I spy a what? Common factor. So let's factor out the cosine, and that leaves us 2 cosine of x minus what? Minus 0 or minus 1? Minus 1. Very good. Equals 0. Remember, keep it equal to 0. Now you said each factor equals 0. Cosine is 0 or cosine of x equals a half. Can you do that in your head when you set the second factor equal to 0? Can you bring the 1 across and divide by 2 in your head? If not, show the steps. If so, that's pushing yourself a little bit like I'd like you to do in an honors level class. Okay, but it's better to show more steps and get it right than try to do it in your head and make a careless mistake. And now it's time circle unit, right, Brady? Between 0 and 2 pi, where does cosine equal 0? Pi halves and 3 pi halves. Anyone here concur?
They're directly on the x-axis, so there's no movement.
They're directly on the y-axis. And on the y-axis, that's where x is 0, right? That's where the width is 0, which is where cosine is 0. So I think I'm going to concur, right? Yeah, well done, Brady. All right, now someone besides Brady, where is cosine equal to positive 1/2? If you want to just keep x equals with commas, you can keep the list going. It's going to be here and here. Is it pi 6 or pi thirds reference? Pi thirds, that's where it's closer to the 90 degrees. So it should be 1 pi third. And then what's the quadrant 4 one? 5 pi thirds. Do we need to check for extraneous solutions? No, we didn't square anything. And we don't need to check to see if any cause 0 in the denominator because we don't have a denominator, right? So all 4 of those work. Kind of getting the hang of it. Quadratics, Pythagorean identities. All right, last one. Letter F. Letter F. Let me give you a couple of minutes to do this one. If you're watching the video, I'm going to pause it. So if you just keep the video playing, it's going to be like no time has elapsed. So Ms. Moore, if you want to pause the video, you can, or if you just want to leave it playing, and then I'll go over with this kids too, that's fine. But here we go. I'm going to give you about 2 minutes, okay, to do this. Go. All right. So I don't know if you pause it, Ms. Moore. I don't know if you're watching at home and you pause it, but if not, we have a squared term and a non-squared term with variables. That's two variable terms. So in that case, we want to get everything on one side it's equal to 0. It doesn't matter which side you collect it on. I usually just typically bring everything over to the left, regardless of how many terms I have on the right. You can also change all the signs if you want at this point. That'd be like collecting it on the right-hand side. But I have cosine and sine squared. And as we already saw, I want to get them in terms of a single trig function. So I'm going to put parentheses around sine squared, because again, we've already talked about it's easier to turn a sine squared into cosine squared than it is to turn a cosine into a sine, because that's cofunction. It changes the angle. So here we go. 2 plus 2 cosine of x, still minus parentheses 1 minus cosine squared of x. Keep your equal to 0. All right, if you distribute now, you're going to get a -1 and a plus cosine squared of x. That's good. Now I'll write it in descending term in order and collect like terms. So I have a cosine squared in the front. I have a +2 cosine of x, and then a 2 minus 1 makes it a +1. Now, if you're doing the worksheet or it's a test, don't be surprised if you have a negative cosine squared at this point. If you do, don't sweat it. That means you just collect it on the other side, multiply everything through by -1, distribute. That's basically changing all the signs on the left, and 0 times -1 is still 0, right? So that would be a negative cosine squared plus a 2 cosine minus 1. No big deal, but it's easier to factor when the leading coefficient is +1. Now this is an easy one because the leading coefficient is +1. So if it's going to factor into the product of two binomials, it's got to be a cosine x cosine x. That's the square root of the first term. 1 is your target product. It's prime, so it's got to be a 1 and a 1. Now, because both terms are positive, it's got to be a positive, and all you got to check is the sum of the inner and outer, right? That's a positive cosine on the inside, positive cosine on the outside. Cosine plus cosine is 2 cosine. Lots of good concert shirts today. I didn't wear a concert shirt today. I wore my BOTC calculus shirt today because my BC kids are taking their calculus exam this morning. But
I wore the periodic table of band.
of band. Oh, nice. Yeah, I didn't even see that. That's a good one. That's good. That's good. So happy music Monday. Music, if it's not metal, music Monday. All right. Now we set them each equal to 0. But wait, aren't those the same? Pena.
Oh yeah, no.
You changed it to Pena.
The new shortstop is Jeremy Pena.
Oh, so you changed the jersey.
So
I like it.
changed Carlos Correa to,
Oh, nice. And you use the A at the end. I like that.
Yeah.
All right. So these are the same factors. So really, I only have to set one of them equal to 0. And when I set it equal to 0, I could bring the 1 across and it's equal to -1, right? And now it's unit circle time. But wait, it's time circle unit. Where between 0 and 2 pi is cosine equal to -1, if ever? Pi. And that's the only answer. So that's it. Do we need to plug it in to check? You don't have to, because we didn't square both sides. It was already squared, and there's no denominator to check to see if it causes 0. So that's the answer. It's a conditional equation. It's true between 0 and 2 pi under the condition that x equals pi. And there you go. That's the end of the notes. So we have simplifying, we have verifying, we have counterexamples, and then we have solving equations, right? Any questions besides, sir, is it legal to have this much fun in class on a Monday morning? I don't know. I haven't looked up the statute, but if you don't tell on me, then it is legal. Okay.
I made sure.
All right. Worksheets due tomorrow at 9 a.m. Notes are due at 9 a.m. You can submit your notes right now into Canvas if you want to. And I think I'll stop recording and we'll listen to I Don't Love You Anymore unless y'all get bored halfway through because it's a slow ballad. And then we'll listen to the Battle of Bob. What'd you say?
Ballad of Bull.
Ballad of Bull. Okay. See y'all.